Hello students, today we are going to discuss about acceleration of a body. We can observe a car can speed up, a car can be slowing down. For example, initially if a car is moving with velocity u, that means initial velocity of the car, let it be u. After some time t, the final velocity of the car, final velocity, let it be v, right? Now what is the change in velocity here? Change in velocity is nothing but final velocity minus initial velocity, that is v minus u in the time t seconds, right? Now see the change in velocity in the time t seconds equal to v minus u. Now what is the change in velocity in 1 second? The change in velocity in 1 second, which equal to v minus u by t. Now the change in velocity in 1 second is called acceleration of the body. Right? We know that in 1 second can be termed as rate. Now the definition of the acceleration is the rate of change of velocity of a body is called acceleration. Now here mathematically it can be represented as a bar. Acceleration is a vector quantity which can be written as v bar minus u bar. Final velocity minus initial velocity by time t. So it is a vector quantity. It can have positive values, positive, negative values. It can be zero also. See, the important point is acceleration. The body experiences acceleration whenever there is a change in velocity only. If a body is moving with constant velocity, the acceleration of the body is zero. The acceleration of the body will be zero. That means what? Whenever there is a change in velocity, there is a change in velocity of a body, there will be acceleration. That means the body experiences acceleration whenever there is a change in velocity. If a body is moving with constant velocity, the acceleration of the body will be zero. Here, the acceleration may be positive, negative, zero. It will be zero. See, the positive acceleration The body experiences positive acceleration when speeding up while moving. The body experiences negative acceleration when slowing down while moving. See, we can also, if the directions of the initial velocity and acceleration are mutually opposite, initial velocity, initial velocity initial velocity, let it be u, and acceleration are mutually opposite, then the particle or a body is said to be moving with retardation or deacceleration. Retardation or deacceleration, this is also known as negative acceleration. Negative acceleration. Now, coming to uniform acceleration. See clearly, if a body is moving with constant acceleration, observe the picture. Here, the velocity changes. The change in velocity is same for equal intervals of time. For equal intervals of time, we can say the body is moving with constant acceleration. Clearly observe the velocity here. The change in velocity is, even it is changing, the change in velocity is same. The acceleration is 1 meter per second. Then we can say the body is moving with constant acceleration or uniform acceleration. To understand, let's see some more examples. Here, I am accelerating because I am speeding up. See, while speeding up, the body or the boy experiences positive acceleration. Now here, I am accelerating. See the second picture? I am accelerating because I am slowing down. Here, the boy experiences negative acceleration. Negative acceleration. See here, while speeding up, here the velocity changes from low to high value. While slowing down, the velocity changes from high to low value. It decreases from high to low value. Now coming to the third picture, here see the bee is moving and changes its direction. It changes its direction. See, I am accelerating. What it said? I am accelerating because I am changing the direction. In this case also, there will be change in direction. Hence, acceleration. The bee experiences acceleration. Now see, average acceleration. See, what is average acceleration? Average acceleration equal to change in velocity by time interval. Time interval. That is, V2 is the final velocity and V1 is the initial velocity, V2 minus V1 by the time interval T2 minus T1. Simply it can be written as delta V bar by delta T, or we can also write dV bar by T. Remember, let X be the displacement. Displacement dx by dt. It is not d into x, not d into t. Dx by dt is the velocity which gives velocity of the body, and d square x by dt square gives the acceleration of the body. Right. Hope you understand the concept of acceleration. We'll connect you in the next video with more examples. Please like and subscribe